Today we're going to look at the difference in sample versus a population. So a couple of things that we need to know. One, what is a population? Now a population would be the whole entire group. So let's say you want to find out what percent of Ohioans drive red cars. Your population would be every single person in Ohio. Okay, now a lot of times it's really not feasible to sample or to survey an entire population. So, because of that, what we often do is we use a sample. Now, a sample is a smaller group that's selected from the population. And the whole point is they can be representative of the population. So rather than surveying every single person in Ohio, I can survey a sample, and if I select them properly, they can represent the entire population, and I can base the results of that sample, or based on the results of that sample, I can get a pretty good idea of what the entire population, what they're like. Now, there's a couple of big ideas that we kind of use when we're sampling. Because like I said, if you select them right, it can be a good representation of your population. But you can't just pick your 5 buddies and say that that is a good representation of all of Ohio. Okay, so there's some bigger things to look at. One, you're examining part of a whole. Okay, so what that means is it should be representative of the whole. For example, a survey of only middle-class Americans is not representative of the country as a whole. We don't have upper or lower class represented in our sample, so that would not be good. If I'm trying to do a sample of Ohio and I only ask high school students, how effective is that? Probably not very good. I don't think, 20 high school students are going to be, especially if I do it all from the same school, are going to be a good representation of the entire state of Ohio and their thoughts and beliefs. Number 2, you have to randomize your survey, okay? I can't just choose to survey this statistics class and say, yep, there's my group for representing Ohio, okay? It doesn't work quite that easily. Randomization, it protects you against known and unknown factors which will affect your data. For example, if I was trying to collect data about the state of Ohio and I chose to only survey this statistics class, well, one thing, I know I'm leaving out part of the group because, a group of high school students is not representative of all of Ohio, and I know that up front. So, by not choosing a random selection of people from the state of Ohio, I'm not doing a very good job of actually coming up with a sample that will in fact represent the whole group. The third thing that you need to think about is sample size. Okay, now sample size is something that is pretty important, but a lot of times it's kind of out of our hands. If we're trying to do a survey of all Ohioans, obviously we're not going to be able to survey every single person. I mean, we're probably not going to be able to survey very many at all. So really our sample size, it might be a little bit out of our hands of how big of a sample we actually get. One thing to keep in mind is it's not the percentage of the population that's important, it's the number of individuals that's important. Okay, so we want to focus on the number of individuals that we have. Also, we want to keep in mind that the sample size should be large enough to get a representative sample. If I only survey 2 people, that is not a good representation of an entire state. Ideally, the larger the sample size, the better. The larger the sample, the more precise your results are likely to be. Okay, now like I said, sometimes that's out of your hands. You're just not physically capable of surveying a large quantity of people. But ideally, the larger the sample size, the better. Okay. Now, one other thing as we're kind of going to start switching back and forth from looking at a population as a whole to a sample and vice versa, we are going to notice some difference in notation. So some of the common ones that we're going to need for sample and population, we've got mean, standard deviation, variance, correlation coefficient, and the number of elements. So just want to give you a little rundown of some of the notation that you're going to be likely to come across now. So let's see here. Whoops. There we go. Okay, so for sample and my iPad's going crazy on me here. There we go. For sample and for population. Okay, first of all, we have the mean. Now, the mean for a sample we denote as x bar. Okay, so that's going to be our sample mean. For population, we're using the Greek symbol mu, and that's going to represent our population mean. And then we have standard deviation. For a sample, we have Sx, and for the population, we have the Greek symbol sigma. Then we've got variance, which for the sample is S squared, and for the population is sigma squared. Next, for our correlation coefficient, for the sample that is R, and for the population that is P. And then finally, the number of elements. For a sample, we use lowercase n, and for the population, we use capital N. So those are just our differences in symbols, some of the common symbols that we'll see when we're looking at a sample versus a population. So it's going to be important that we know those and can distinguish between those and know what each one represents.